there was actually a vulnerability that came out about a week ago for PHP-BB, or maybe it was vBulletin, I forget. But they have something where a user can insert a URL into their post by doing bracket URL equals the web address and then end bracket. Well, what you could do is you could enter bracket URL equals JavaScript colon and then JavaScript. So what's known as a JavaScript URI. And when that URL is activated by the user clicking on it, they then execute JavaScript. So even then, when they had some type of meta HTML language to try to not actually have tags the browser could understand, you still could execute script. So just what are some of these design issues that we're kind of all talking about? The fact that requests can be made with the XML HTTP requests that are identical to the original request is a problem. The server cannot tell the difference. You cannot repudiate traffic that was created by AJAX. You cannot prove that you didn't do that. Consider this in a stock trading site. Think about myspace.com. You view one page in well, we said 4 minimum, but then he went ahead and updated your profile, or updated your heroes list and added you to your friend list. Looking at one page caused 4 to 6 requests to be made without your knowledge, and from the server's point of view, nothing bad happened. That's what's really funny about this Yahoo thing, right? From Yahoo's point of view, here's what happened. I checked my mail. I opened a message. About a second and a half later, I made a request that said, I'd like my address book. About a second later, I made a request to Yahoo saying, I'd like to compose a mail message. About a second after that, I said, please send this mail message. From Yahoo's point of view, nothing is suspicious, other than maybe the timings, but with JavaScript, I can say, hey, wait a couple of seconds before you do this next thing. That's what's so scary about this, is the server can't tell that anything bad is happening. We're exploiting the trust between the client and the server. So I really want to push, I really want to see, the browser manufacturers who are implementing the different ActiveX objects and different things to actually instantiate the XML HTTP request. When you make an XML HTTP request, the browser should stick an HTTP header that simply says request made by user event or a JavaScript event. The server needs to be able to know where these things came from because it doesn't right now. Yes? Well, but certainly, but you're directly attacking. That's when you're directly contacting and attacking the web application. I'm just saying, from a propagation point of view, if I had let's say MySpace or Yahoo, because that's the other thing. You asked the question earlier about what about the application being AJAX enabled? The Yahoo Mail client wasn't AJAX enabled, but AJAX was used to steal addresses. If Yahoo had had something in there, look, in their little thing, the page to say, get me my address book. If they had a little thing saying, hey, if the HTTP header doesn't say, or if the HTTP header says this was made by script and not a user event, ignore it. Yeah, you could directly contact it with Perl, but that's not self-propagating because that's where the JavaScript has to propagate itself. And then what that means, though, is you could write a propagating worm in Perl, which I'm going to talk about this afternoon, but this is trying to defeat cross-site scripting propagation in AJAX. Does that answer your question? Okay, cool. Yes?
Can we use client certificate on the client?
Certainly, but please show me an organization that's implemented client-side cert successfully besides really, really scary government organizations. I mean, client-side certs, they're really good. Client-side certs would be great. I have never seen anyone do client-side certs properly. I really haven't. And a lot of, I don't know. First, well, here's another thing, right? Do you have a client-side cert for MySpace? Do you have a client-side cert for Amazon? That's the beautiful thing about SSL, right? When I connect to SSL, I've got a pretty good idea because Amazon's got a server-side cert that I am in fact talking to Amazon. Amazon has no idea who I'm talking to, and frankly, Amazon doesn't want to know. Amazon doesn't want to have to manage client-side certs for millions and millions of users. It's not practical. In a closed environment like the government, when you have a limited user pool, that's great. But if I was running an e-commerce business and I said, look, to talk to me, or a web mail, say, to talk to me you need a client-side cert, nobody would use me. Because the whole point of having web applications is I can use them from everywhere. If I'm on the road, I'm at an internet cafe, I want to check my mail, I don't want to have to somehow, cart my private cert around on a PGP, or a FOB. I mean, it's a good idea, but it won't work in a lot of these types of applications. And even when it does work, people don't really do it right. Is that good? Was there another question I saw over here? Yes? we're going to get to that. But I mean, remember, everything I'm talking about here totally transcends frameworks. This is simply JavaScript making HTTP requests on your behalf. There's nothing, I mean, this doesn't even deal with frameworks because when I'm injecting a cross-site scripting attack, I'm probably not, you know, injecting a framework along with my attack. It's custom. So this really kind of transcends different types of frameworks. But when we get to bridging, that's where you've got the fun implementations and frameworks. Yes? Oh, I'm sorry. Actually, that's a very good point. The beautiful thing about the browser, right, is the browser does so much for you. It goes, oh, you're making a request to Amazon. I've already got a cookie for Amazon. Let me slap that in. Or, oh, you're making a request to your browser, you know, your little Linksys firewall, 192.168.1.1. You've already cached those credentials with me. I'm going to go ahead and slap those credentials in for you. Which is why, actually, Jeremiah this morning, he was able to use an image object to send credentials to the browser. Because the browser goes, oh, you're going to this host? Hold on, let me check. Yeah, let me tack this stuff on there for you. So it's nasty. Ooh, I'm going back. So cross-site scripting is already dangerous, right? I mean, Spy Dynamics and White Hat Security actually both released, White Hat Security today, Spy Dynamics last week, released how to port scan in JavaScript. And it was really funny because Jeremiah and I were talking last night at the WASC meeting in the Shadow Bar, and it's kind of like, how did you do fingerprinting? And he's like, I used cascading style sheets. And I'm like, wow, we used image objects. So Jeremiah's presentation in the conference CD has his proof of concept. If you go to spydynamics.com right now and go to our Spy Labs, our expert articles, we wrote a white paper about this, and we've got a nice little piece of a proof of concept code where you can give it a range of IP addresses, and it'll just start scanning and popping up. We'll actually fingerprint the web server. We'll go, oh, here's IIS, here's Apache, and it just runs along. Actually, the way we did is we used image objects, and we say, hey, here's an image object, and if an error event fires, that's how I could find out whether there was a box there or not. And then I would then use an iframe and an onload event to determine that it was in fact HTTP that was coming back to me and not some type of server banner. And finally, we would use image objects to request known images and then check their dimensions to try to fingerprint the device. So none of this that I just talked about is using AJAX, and it's already really, really bad. AJAX now allows JavaScript to make requests on your behalf using your credentials, and the server can't tell the difference. This is catastrophic. Yes? No, that's the interesting thing. Well, I'm sorry, let me take that back. That's why I was talking about using cross-site scripting propagation without AJAX. It was kind of talked about in the early 2000s. I never saw it ever in the wild. People kind of academically talked about it. And the problem is all these little things like image, on air, frame, on load, from JavaScript, I can never actually see the content that comes back. I don't get to see status codes. I don't get to see HTTP headers. These are kind of using side channels, and it's a dirty hack to try to do port scanning. But remember, AJAX, you couldn't port scan with AJAX. But, for example, consider the MySpace thing, right? Like, I made a request. It came back saying, are you sure? And included in the request was a little hash. And I had to extract that hash and then make a request to the yes, I am really, really sure page. And if I hadn't extracted that hash and submitted it to the second page, it wouldn't have gone through. So you really do, good God, you really do, for these propagation methods, need access to the response. So AJAX bridging. You were talking about AJAX frameworks. So let's talk about what an AJAX bridge is, because this is just fun. And I've got about 30 minutes left, I think. All right. You guys having fun? I'm not getting too many questions? All right, good. Yeah, thank you. All right, this is destroying the internet. This is fun stuff. Okay, so AJAX bridgings is a complete hack. It's to overcome this limitation in the AJAX implementation. Basically, it provides a bridge between client-side script so it can access web services, content, and stuff on third parties. It's literally a web service to another web service. How does it work? Well, like we said, AJAX can only connect back to the host it came from. To allow scripts to go talk to some third-party site, you know, for example, I'm BillysBooks.com. I want my web services or my AJAX that I push down to the client to be able to talk to Amazon. Can't talk directly. So on BillysBooks.com, I open a web service, and then everything that comes into that web service, I basically analyze slightly, and then forward it to Amazon. Amazon responds to the web service, and then the web service responds to the JavaScript. Yes, Andrew. Yes, Adobe has some stuff, the Flash bridges. It's the same concept. Whether you're using a web service or whether, exactly how you're implementing the bridge kind of varies from framework to framework, but it's just literally a proxy. This JavaScript needs to talk to some third party. We need to provide a proxy so it can do that because there's a design limitation. Actually, yes, that's the beautiful thing. Applets have the exact same restrictions that AJAX has. If you download an applet, a Java applet to your machine, it can make socket requests. It's only allowed to make socket requests back to the server it came from. Specifically, I don't know if it has the port limitation. I think it's only the host name. Interestingly enough, signed Java applets can make HTTP requests anywhere. So the same way where people are like, yes, yes, to every message that pops up, I could push something down that says, this is a signed JavaScript applet. Do you want to run it? Yes. Okay, great. I'm port scanning you now. And more importantly, I'm port scanning you and I can see the responses because I can actually analyze and open sockets anywhere. There's actually a beautiful applet called MindTerm, I think. It's, if you type MindTerm or just simply Java applet SSH client into Google, you'll find it. It's a great way if you're at a browser and you need an SSH client, you just pop this up and it says, would you like to use this signed applet? And you're like, sure, because I'm right here and who cares about this kiosk? And you now can make SSH connections anywhere. In fact, is there anyone here from the federal government or the Library of Congress by chance? I really don't want to get carted away. But a couple years ago, I was up in DC at the Library of Congress and my VP of engineering is there going, oh my God. There was I wanted to check my mail, and MindTerm actually has built into it a secure copy, so you can pull down files. And so in the Library of Congress, we used MindTerm to go connect to people, and we could use secure copy, even though the machine was locked down, you couldn't copy stuff. We pulled down Scorched Earth and started playing Scorched Earth in the middle of the Library of Congress. But we didn't realize that they still had the speaker plugged in, the internal speaker. So you send that first nuke flying across the screen, it goes, woo, boom. The librarians kindly asked us to leave. So, all right. I just see Jaime there going, oh God. I'm going to get a talking to afterwards. I hope you all enjoyed the story. I'll enjoy my imprisonment. So yes, you are correct. There is, applets can do this too if they're signed. And like I said, many frameworks support bridges. You can do custom implementations like CGI gateways, ASP, PHP. All the popular frameworks support AJAX bridging. So data over the bridge. Well, what third-party services can this bridge talk to on behalf of the web service? Well, I can go contact a web service running on any host and talk SOAP to it, REST, maybe some type of custom XML protocol. I could just go connect to some arbitrary resource. I could have a web service on billysbooks.com which pulls up arbitrary things from Flickr, or goes and pulls the very first image off Google Images and pulls that back down. For I type in Stephen King and to billysbooks.com. Billysbooks.com goes, hey, Google Images, give me the first JPEG for Stephen King. Pop that back. So arbitrary web resources also, we could grab SSH feeds, we could grab raw content, HTML, Flash, any type of resource. What does this bridge return? JSON. JSON is just a way of serializing complicated objects in JavaScript. And the scary thing is basically